Okay, great. Yes, I'm a music teacher and I also work as a kind of a IT support for my fellow teachers at school. I have always been interested in computers, and actually I could have joined your earlier conversation about old computers. I loved to program on. Actually, I learned to program writing machine code on a Sinclair computer, ZX81, I think it was. Great
Awesome.
times. At
Yes.
at at some point, the main interest lie in games, writing games, but at some point the game industry went so far ahead with all kind of 3D graphics and everything. So I left all that. But at that moment, I got introduced to microcontrollers, and it was kind of getting back to the really fun thing, writing code and making things do something. So I'm going to present my, oh, I have to share my screen like this, yeah.
Yep.
I'm going to present my Glockenspiel project, which actually is not quite finished yet, but you will get to listen to it. My presentation is about, I'm going to tell some backgrounds why I started this project and a few words about what a tubular Glockenspiel actually is, and the working principle of my actual Glockenspiel, which is the nice old furniture you see here in the picture, and a few words about the electronics, and that will give a good start for the last part of the presentation, where I tell something about how I use the RT Thread Studio software to get everything working. And so the background to the project started actually at the time where I kind of shifted from writing computer games just for fun to writing stuff for microcontrollers. It was some 7 years ago. I had started, actually, our school principal asked if I could do something at school, teach children something about electronics and stuff. And that way I got interested in it. At that year, it was 70 years ago, something. I made a trip to Denmark, and I saw some churches with very beautiful carillon things, these fantastic bells playing melodies from the church towers. And that gave the idea to build something similar. So my first project was an actual Glockenspiel. You can see here in the video some keys from a normal chromatic Glockenspiel. I simply took the keys and built this little machine, which could play something. I made it play through a computer. I just connected my computer to the microcontroller, and it started to play from the music writing software I used on the computer. So it did something like this. Okay, and the tune you can hear here is actually one of the tunes I heard in a church tower in Denmark that first, well, that summer 7 years ago. My next project was turning an old reed organ to a mechanical player. And so on. Oops, like that. Yeah. And then 1 year ago, there was this RT thread contest at Hackster. I joined it with this very project I'm presenting to you right now. Unfortunately, I couldn't finish the project in given deadlines because things happens. I happened to fire get the board toasted that I was supposed to use for the contest. I ordered a new one, but I never got it in time, and then other things happened, and the whole project I just put it on wait. And actually, I've been working on it lately again, and I have a very working model of the Glockenspiel already. The Glockenspiel is a kind of tubular Glockenspiel, and I explain it shortly here. Normal tubular bells that Max referred to some minutes ago looks like this. It's an orchestra instrument. The sound of these tubes, long tubes, are very like church bells, and they actually are not very suitable for playing melodies, especially if you want to combine many tones, like hitting many keys on piano at the same time. But if you take smaller pieces, then you get very beautiful sounds from these tubes. And I loved the sound that comes from these tubes because they have a very long sustain compared with the normal Glockenspiel you heard in the earlier video from my first Glockenspiel project. So I was going for these tubes instead. The tubes have to lie on this bed, and when you support the tubes exactly at these nodes, which are always 22.4% from the end of the whole length, then you get the beautiful sustain. Trying to support them from any other point will just damp the sound too early. So here we have some fundamental calculations you need to perform to get the right lengths of the tubes. And maybe I just skip, but it works like this. I kind of need to find a constant for the type of tubes I use. So what I did was I cut two pieces, the length of which were 242 millimeters and then 223 millimeters. I measured the frequencies of these tubes, and that gave me a constant that I could use in future calculations to get the right length of the tubes. And that gave me the right length for 32 tubes that I use in my Glockenspiel. Each tube has a solenoid hitting the tube from below. And here I'm about to attach these tubes. I have three shelves with some 12 tubes on each. And here you can hear the beautiful sound from these tubes and the beautiful sustain that you have. This leads to an instrument where you don't actually feel the sound after you have hit it. You just let it ring. After I had mounted all the tubes of one board here, I could actually play a melody just hitting these. And this is a single melody, but they actually sound very beautiful when you strike 2 or 3 of these at the same time. Everything is controlled by this board, and this was the board that I got from the competition, joining the competition 1 year ago. Well, this is not actually the same species example, because as I told, I toasted the first one and then I bought this second one. Here I just test a few things that I added to my project: a LED showing some color lights and a rotary switch. And those were included later in the project. I also included an LCD screen. I chose an LCD screen. It sounds a little bit old-fashioned already, like going back 30 years in this technology, but I think it suits very good, very well this project, because I'm using this old piece of furniture for the frame for the whole instrument. And the rotary switch I already mentioned, and the RGB LED light also. And here you can see the LED LCD screen. I tested some trying to calibrate the right force for the solenoids to hit the tubes. And here is the RGB LED in action. And this kind of user interface will be in the final product. Let's see, I have to stop this. Okay, it was stopped. Yeah. A few words about the electronics. When the strike is about to happen, I send a simple digital signal to a set of transistors, which open the current from a 12-volt source going through the solenoid and sinking through the IC Darlington set of transistors. And this might be from an earlier version where I tested the system. Anyway, For the project, I also created my own PCBs. I have an Hackster project page actually showing how I make these PCBs. I start by using just any software for designing this. I take the graphics over to Inkscape, where I produce some G code for my CNC router, which you can see here. Yeah, and this way I can produce these PCBs. This is the actual PCB for my Glockenspiel. And here is the secondary PCB for the user interface. Here's for the RGB LEDs and a rotary switch and a 3-position switch we have here. And then finally, about the RT Thread Studio. I love to use it because I can write in C and C++, which happens to be my favorite programming languages. It also seems to be a very easy software for adding libraries, writing your own libraries and modifying code. If I will take a small glimpse at what I have here. For an example, to get the LCD working, I found this marvelous software written by Raivis Strogonovs from Latvia or Lithuania, either. And it's old, it's 11 years old software. So I wrote some modifications for it so it will work with the board I use here, which of course uses the routines and libraries from the RT thread libraries. So my modification turned all calls to pins, data pins, to the right calls in the RT thread and libraries. And that was about that. And yeah, my project at the moment is, at this stage, I need still to write some programs for calibrating the right force for each key, for each tube, so they will sound even. You will hear a small sample at the end of my presentation where you can hear that all strikes are not quite even. And I'm also going to add the RW007 module, which came, I remember it came with the board when I joined the competition. I never got this working yet, but it's a part of the you can see it in my code. It's just waiting here to be deployed. But the thing is, I want to make my whole Glockenspiel work as an IoT device. I have this web page where it's meant for anybody to be able to make a playlist here. You just click here on tunes you want to listen, and the device starts to play these tunes in order. And when it has played, then the tune is deleted from the playlist and the next tune starts again. This side, this page works perfectly already, but I haven't got this piece working with the main board yet. So that's on the to-do list. So finally, I could play this video. Here is the as you can see, I don't have the user interface, the LCD screen and so on. They are not attached here, but here we can see the board and my PCB lying here, and a lot of cables running to the tiny solenoids. So I will end my presentation if I don't get lost in all these. There we are. By playing this. So it will sound like this. This was a very simple tune. Actually, it's so simple because I have managed to lose connection to some of these, so I couldn't use any of the 32 notes. So I couldn't actually play the tunes I already have programmed for the Glockenspiel. I have them in a data structures like this. We have 6 tunes here already, and each note is coded in a MIDI kind of way. We have a timestamp, the number of the notes, and the strike force or velocity of the notes. So when I get all connections fixed here, I will be able to play at least these 6 tunes I've already coded for the machine. So that was my project.
That is absolutely awesome, Johan. So you're going to actually have it so that you can strike the control the solenoids to strike the notes lightly or heavily?
Yes, that's the idea. But for that, I have to calibrate them, because I can't use the same force, the same parameters for each.
Well, no, because every solenoid is going to be slightly different. So what you'd really want is to have some sort of sensor that detects the strike force and fine tunes it. For this sort of thing, my understanding is that you can't just go down to the hardware store and buy a length of copper pipe. It has to be specially hardened pipe to get the right notes. Is that true?
No, you can use just any kind of pipes. This is aluminum pipes. And actually, I bought first another kind of aluminum pipe with much thicker aluminum. It costed more, and it was of no use. Then I bought these ones which are thinner material, and they sound just great. I have also tried used copper tubes with chromium, some kind of a surface, and they sound very good. Actually, just any tube sounds good, but you have to cut them in the right length.
Oh yeah. Somebody says here, Louis says maybe using PWM for the solenoids to control the force.
That's of no use because the time.
No, because you just want it to go on and off. Yeah.
Yeah, and it's only about what you just heard was 15 milliseconds of strike of force. And that was actually too much. It made too much noise.
Right.
So it's somewhere around between 5 and 10 milliseconds. If it goes below 5 milliseconds, the small peg won't move fast enough to reach the tube. So there's around between 5 or 10 milliseconds. So if you use PWM, you have to use a very, very high frequency
Right.
to actually make it matter.
My head is buzzing now. I want one. Do you mind if people contact you, or do you mind posting your GitHub page, or?
Let's see, what could I do? I have, as I said, I have this on Hackster.
All right. Well,
So
could you post that Hackster page?
yeah, I could do that. I shall post my, I don't know, actually, well, my Hackster profile page is here. And from there, people might find this project I've just showed. I have this Glockenspiel described on its own page, even though the
Awesome.
whole thing is a working progress still.
I've just put
Because
my email there. If you care to email me, we can link up. Because I've got tons of questions. I want to build one. Thank you so much. That is a wonderful talk. I think most of us love to see what other people are doing. And I bet there's a lot of the people listening to this now are thinking, I could make one of those. I want to make one of those. So.
Well, it's a great fun to build these, and it's a little bit like the journey is the most important thing. But
Yes. Well,
yeah,
you learn a lot. Anything like
yes.
this, you learn tremendous amounts, like controlling the solenoids and things, stuff that you might not learn normally in what you're doing in the everyday job. But I personally have found that everything I ever learn comes in useful sometime in the most unexpected ways often. So, and here's something else. I don't know if you've ever seen this. Have you heard of Annie Music?
Any
That's
music?
it's the people created a 3D world of instruments, and they used MIDI to program it. But
Oh yes.
it reminded me very much of what you were doing.
Mm-hmm.
Thank you so much.